Good morning, dear students. Today we'll solve the problems on first order low pass Butterworth filter. Before we solve the problems, under the first order low pass Butterworth filter, we have to know what is a frequency scaling. So frequency scaling is nothing but once the filter is designed, sometimes it is necessary to change the value of cutoff frequency is FH. So the method is used to change your original value of cutoff frequency FH to a new cutoff frequency FH1 is called as your frequency scaling. So we'll start with the today's problem. That is, the problem statement is: design a first order low pass filter with a cutoff frequency of 1 kilohertz and a pass band gain of 2. Okay, so we have to design a first order low pass filter. For that, what data we are having is, that is FH. So FH is your cutoff frequency. That is FH is equals to 1 kilohertz. So you know the steps under the design of first order low pass filter. First we have to choose the cutoff frequency FH. So second, we have to choose the capacitance value, usually between 0.001 and 1 microfarad. So we'll select the capacitor value generally as 1 microfarad or less than that. So we'll take the capacitor value as C is equals to 0.001 microfarad. So third step, we have to calculate the R. To calculate the R, which formula will use? That is FH is equals to 1 divided by 2 pi 2 pi RC. So R is equals to 1 divided by 2 pi FH into C. So we are having the value of FH and as well as the value of capacitance. So that is 2 pi into FH value is 1 kilohertz, right? That is 1 into 10 raised to 3 into C is 0.001 into 10 raised to minus 6. So once if you calculate, before you calculate these R, please use the proper brackets. So once if you calculate this R, you will get it as 159.15 kilo ohm. So this is not your standard value. To get the standard value, you have to refer your typical standard resistor values. So see here, anywhere is 159.15 kilo ohm is there. So here is 150 kilo ohm is your standard value. So use 150 kilo ohm as your standard values. That is 150 kilo ohm. Okay, so your R value will be 150 kilo ohm. So next, last, we know the AF, that is 2. If we know the AF, we can calculate the RF by R1. So what is RF by R1 is? AF is equals to 1 plus RF by R1. So we know the AF is 2. 2 is equals to 1 plus RF by R1. So therefore, your RF by R1 is 1. Is it? So your RF is equals to R1. That is RF is equals to R1. So now we'll design your first order low pass filter. That is minus plus, this is R1 is your V in. This is your RF. So RF is what? This is R1. This is R. This is C. This is V out. So C value is 0.001 microfarad. Okay. So your R is 150 kilo ohm. Your R1 is, you can write it as, instead of taking 1, choose RF is equals to R1 as 10 kilo ohm. So your RF and R1 will be 10 kilo ohm. So this is the design of your first order low pass filter. So second problem we'll solve. So that is, for a low pass filter, a cutoff frequency is 30 kilo radian per seconds, and the capacitor selected as 0.01 microfarad, you can say. Then determine the corresponding value is the resistance required. So problem statement is what? For a low pass filter, a cutoff frequency is 30 kilo radians per seconds, and the capacitor selected is 0.01 microfarad. So determine the corresponding value of the resistance is required. Okay. So we'll solve. So what all data we are having is, that is capacitor we are having, that is 0.01 microfarad, and your omega h is equals to 30 kilo radian per seconds. So you know omega h is equals to 2 pi f, that is 2 pi fh. So how you will calculate fh? Fh is equals to 1 divided by 2 pi rc. Okay. So in this we'll put this fh value, that is omega is 30 kilo radian per seconds, right? So 30 into 10 raised to 3. So 2 pi into 1 divided by 2 pi into r into 0.01 into 10 raised to minus 6. So to calculate this r, so r is equals to 3.33 kilo ohm. In this problem also use the proper brackets while calculating the value of r. So next comes your assignment problem. You have to solve it. So that is design a low pass filter, a cutoff frequency is of 15.9 kilohertz with a pass band gain is 1.5. So this is your homework problem. Please read the statements. That is, design a low pass filter, a cutoff frequency of 15.9 kilohertz with a pass band gain is 1.5. solve this problem. Okay, so next comes is your second order low pass Butterworth filter. Okay, so under the second order low pass filter, this is a circuit diagram. Again we are using the non-inverting configuration. This is your R1, this is your RF. So this circuit is called as your feedback resistance. Okay, supply, this is your R2, this is R3, C2 and C3. This is A. So under the second order low pass filter, first order filter can be converted into second order type of filter by using your RC network. So this part is your RC network and this part is your feedback resistance. Okay, so this second order low pass Butterworth filter is also called as your double pole low pass Butterworth filter. Why we are calling it as double pole low pass Butterworth filter? Because we are connecting the one more RC network to the non-inverting configuration. Under the first order low pass filter, we are having only one RC network that will be connected to non-inverting terminal. So under the second order low pass filter, we are connecting double pole of your RC network to non-inverting terminal to get the gain or else to get the output. Okay, so next class will derive the derivation for the second order low pass Butterworth filter. Thank you.